Yes, very good afternoon, children. Uh, Today's class is a continuation of the earlier classes. Uh, One humble request. I want you all to go through the video of this lesson repeatedly. I'm send for each for most of the each examples. I'm sending separate videos for which needs an elaborate explanation. I tried my level best to explain through the video because we know very well how it's difficult for you also to understand our concept, the new concepts. Is it clear? We tried, and if it's in class means we would have queried, questions would have been raised based on the explanation, and we could have gone for a better explanation. But unfortunately, in this pandemic situation, we assume whatever we are teaching reaches you. If there's any doubt in the lesson or anything, please clarify it after going through the videos. I'm seeing some people are responding without seeing the video. So the test that we are giving is only for your response. So clear? But the video that we are sending is to for you all to see it repeatedly. Especially as this chapter is concerned, I've taken care to explain each problem mostly in separate videos. Okay, so it's difficult to understand children. So please go through again and again. I'm repeating, go through the video again and again. Then only you can understand the concept. It is similar to your maths. Okay? Yes. So last week we have seen, last class we have seen about the invariants and recursions and some of the examples. I was not able to explain in detail. I'll explain very few examples, which I marked it as star now. I've explained it already in the last class. Okay? Compute a to the power of n in an iterative method. The chocolate pieces which has been divided where my pieces will be B and C will be my cuts. Clear. And this example, sparrow and tree, this example, and refer to the statement of the problem in your textbook. I've just given the headings. You go through the statement of the problem. That's why I've given the textbook number itself. For your example, I've given the textbook number itself. The statement of the problems are very lengthy. You go through the problem and the understand it, and the respective explanation I'm giving through either through separate videos, clear, and some cases I'll combine and give it clear. This I've told in the last class. Chocolate pieces I've told in the last class. Today video I'll be sending for this example, and chameleons have already been explained. Jar of marbles, again I'll be sending you the video for that. Clear. uh, Customer standing in queue. This example I've explained as a student and teacher. Student standing in the queue and teacher is requesting how many students are there in the line. This I've explained using example, using your thing, using your iterative method and using your recursion method. And next example is going to be same thing, compute using recursion has already been taught. And last one is going to be about your square, for which a separate video will be sent. So these are all your examples in your textbook. Clear? Whether you're going to get it for the exam or whether you're going to learn it for the exam and write and all, it's what is there in the textbook. These are all a very interesting topic to solve your puzzles. At least what is given in the textbook, I'm trying to explain something. Please understand it. 8.1, 8.2, 8.3, 8.4, I'll explain now. Is it clear? Yes. See, first of all, there's a question in your thing. Now, thing is, they are asking this is UV is equal, first exercise, UV is equal to 20.5, clear, and UV is equal to U plus 5 comma V minus 5. They are changing the value of U and they are changing the value of V, and then they are asking to prove U plus V is invariant. So what is a general concept or general way of proving is uh, what is the value of U and V before, and what is the value of U after substituting the value, whether before substituting what is my U plus V, after changing this U to U plus Y and V minus Y, what will be my answer u plus v. In both the cases, if my u plus v answer is same, means then I say u plus v is in there. So the logic goes with uv is equal to 20 comma 15. Clear? And my after value substitution change value is u plus 5 and v minus 5. The logic is before first time my u plus v, when my value is 20 and v is 15, means u plus v is equal to 20 plus 15 is equal to 35. Now after assigning the value, u plus v is equal to what? My u value changes to 25 and v value v minus 5, which is mean 15 minus 10. So 15 minus 5 is 10. Now when I add after giving u value as u plus 5 and v value as v minus 5, after changing the value of my variables, what is my u plus v? My u plus v is again 25 plus 10, which is equal to 35. So before also it is 35. After changing my value also it is 35. So my u plus v is invariant. Can you understand now? Yes. Same way. P minus c is 10 comma 9. We have to prove P minus C is, after changing P to P plus 1 and C to C plus 1, we have to say in both the cases, in this case as well as in this case, my P minus C value should be same. Then you can say my P minus C is invariant. So before, first time, what is when my P is 10 and when my C is 9, what is the value of P minus C? Don't confuse with this expression and with this. Our variant is what? Our expression is what? P minus C. Okay. You have to prove that P minus C is same in both the cases. In 10 comma 9 as well as after increasing it by 1, it should be same. So P minus C is equal to, in the starting stage, for 10 minus 9, 10 minus 9 is equal to 1. Okay. Now in this case, what happens? Second case, I'm increasing my 10 by 1 and 9 by 1. So what happens? P plus C, you substitute this P plus 1 and C plus 1 over here. P is equal to what? P plus 1. C is equal to what? C plus 1. Minus of C plus 1. Sorry, this is 1 children, that's not 11. C plus 1. Clear. So now, as usual, algebraic problem, P plus 1 minus C minus 1. Plus 1 and minus 1 and goes off and get my answer as P minus C. What is P minus C? P minus C is 10 minus 9, which is equal to 1. So in both the cases, I'm getting the same answer as 1. So my P minus C is invariant. Okay. Yes. Coming to the next example, 8.3. Here they have not given the value. They have just simply said, there in this case, they have given the two values. Okay. They have given the two values, P minus two expressions. Can you see the difference in your example? Uh, they have given the they have given the value and they have given the changed value, changed expression, and they are asking you to prove it. Here they are just asking you to prove whether this is an, in general, to prove whether this is an invariant. Can you understand? Yes. So now you can ask, what is the initial stage in this? What is the before stage and what is the after stage? Before stage is going to be my P minus C. If you have the value, you substitute and see. If you don't have the value, that P minus C is my before stage. So now after stage P minus C, what you're going to do? You're going to substitute P in place of P plus 1, similar to that explanation. Minus of C plus 1. So P plus 1 minus C minus 1, what is my answer? Plus and minus 1 cancels. I'm getting my answer as P minus C. So before also it is P minus C. After also it is P minus C. So my answer is P minus C is invariant. Can you understand? Before, what is my, if you have the value, you substitute. If you don't have the value, you just take that P minus C itself as your before expression, and after substitution, you're getting back the same answer. Then you say it is invariant. Same way, see over here, changed one is m plus 3 comma n minus 1. Changed expression is m plus 3 comma n minus 1. What I have to prove it as invariant? M plus 3n as my invariant. So before case, my answer before case is what? M plus 3n. So after means, after substituting this value in this expression, I should get back n plus 3n. So that is the meaning of invariant. So m plus 3n. So what is the value of m now? M plus 3. What is the value of n now? N minus 1. So 3 into n minus 1. So now simplify this. M plus 3 plus 3 into n is 3n plus 3 into minus 1 is going to be minus 3. Plus 3 and minus 3 is going to be 0. I'll get my answer as n plus 3n. So before also it is n plus 3n. After I change my m value and n value also it is n plus 3n. So my n plus 3n is invariant. Okay. So these are the four examples in your thing. Yeah. So similar example you have in your choose. See, the three concepts, what is before, what is after. In both the cases, if they are same means, you say it is invariant. If it is not same means, you call it as not variant. Okay? Here there is an example in your choose. Similar exam, similar solution, you have it in your choose. But the choose is a different concept. மேத்ஸ்ல எப்படி நிறைய மெத்தட்ஸ்ல நம்ம வந்து ஒன்று வேல்யூ கொடுத்துட்டு எக்ஸ்பிரஷன் கேட்பாங்க இல்லை எக்ஸ்பிரஷன் கொடுத்துட்டு வேல்யூ கண்டுபிடிக்க சொல்லுவாங்க. ஸோ அதே கான்செப்ட்ல இப்போ நமக்கு ஃபர்ஸ்ட் என்ன பார்த்தோம், வேல்யூஸ் கொடுத்துட்டு பி மைனஸ் சி ரெண்டு கேசஸ்லையும் சேமாக இருக்கா, சி பிளஸ் ஒன்னும் பி பிளஸ் ஒன்னும் சேமாக இருக்கான்னு பார்த்தோம். அடுத்து வேல்யூவே கொடுக்காத இந்த இன்வேரியன் பி மைனஸ் சி வந்து மாற்றின உடனே எப்படி இருக்குன்னு பார்க்கணும். But after that, now we are coming back to this. They are asking you to prove MA, that is actually this is MA plus NB is invariant சொல்லி இருந்தா அப்போ என்னோட m வேல்யூ என்ன, என்னோட n வேல்யூ என்னன்னு கேட்குறாங்க. இதுக்கு முன்னாடி ப்ராப்ளம்ல பியோட வேல்யூவும் சியோட வேல்யூவும் கொடுத்துட்டாங்க. In this example, they have given the p value 10,9 and you substituted in this and you prove, and this is my changed increase changing expression. சேஞ்ச் பண்ண உடனே என்னோட வேல்யூ என்ன, இப்போ என்ன பண்றாங்கன்னா இந்த 10,9 என்னன்னு கேட்குறாங்க, இந்த வேல்யூ கண்டுபிடிக்க சொல்றாங்க. They're asking you to find out this value for my mn. My expression is m plus 3n. My expression is m plus 3. This is my p instead of p minus c. I'm having it as m plus 3n. And see how they're changing this 3 expression. Can you understand? Yes. Then we'll go back now. I'll go back now. Which is, sorry, this one. See, now this is my invariant. Okay? My ma plus nb is my invariant. So if I know means I would have substituted my values and I got the answer before and after. I don't know my value. So now what is before? Before statement is what? My invariant itself, p minus c itself is my before statement. So ma plus mb is my before statement. So after statement is what? M. What is the value of my a plus 8 plus n. What is the value of my b? B has changed to b plus 7. When you multiply, you get your answer as ma plus 8n plus nb plus n7. This we have, this is the before stage and we are not proved still. Yeah, we are not proved still. So this is my before state and this is my after statement. For which value of my m and for which value of my n, I'll get back the same statement. For which value of my m and for which value of my n, I'll get back my ma plus mb is my working out the problem there. So in your choice, first choice I've given the m value as 8 and n value as 7. So I'm substituting here. So I'll get my answer as 8a plus 7b. 8a plus 7b. After substitution, after you change, see what is the after expression? ma plus 8m plus mb plus n7. Either you can go like this way or you can go through this expression. I've gone through this expression. 8 into a plus 8 plus 7 into b plus 7. When you simplify this, 8a plus 8 into 8, 64 plus 7b plus 49. So when you simplify this, I'm getting 8a plus 7b, 64 plus 49 is equal to 113. 8a plus 7b and 8a plus 7b plus 113 is not the same. So this value is wrong. This is not my value of m. Both must be same. Now coming back to this, m is equal to 7, n is equal to minus 8. So I'm substituting it over here. So I'll get my answer as m is 7a minus 8b. This is before. After substituting 7a plus 56, 7a, 7 8s are plus 56, minus 8b minus 56. Can you understand? So when I simplify this, I get my answer as 7a minus 8b, which is same in both the cases. So my value of m is 7, my n is equal to minus 8 is the right choice for this. If you have any doubts in this, you please send your clarifications to my number. Okay? Yes. See the next one. The next one they are asking which is not invariant. Not invariant means what? Before and after must not be same. Before and after should not be same. See what is my statement over here? What is my invariant statement? M plus 2 and n plus 3. M plus 2 and n plus 3. Which is my no value, nothing. Which is my invariant statement? They have given it as a choice. The invariant statement, they have given it as the choice. So my invariant is m mod 2 before. Okay, my invariant is m mod 2 before. So after substituting m plus 2 mod 2 same. Why I am saying this? You have not given any values, you have not given anything. How can you say both before and after same? Any number, whether it is odd number 1 plus 2, you're going to get it as, 2 plus 2, you're going to get it as 4. Can you understand? Same when you divide by 2, either you will get a mod means reminder. Mod means you divide your number. This is my number. This is my divisor. When I divide, this mod function will give a reminder. So whether I'm going to get a reminder using this function for whether it's an odd number or whether it's an even number, I get my reminder as 0. If it's odd number, I'll get my reminder as 1. So it works the same. Anyhow, and this m mod 2, whatever may be the value of my m, I'm going to get a reminder either as 0 or as 1. So this m mod 2 is also a function to get your reminder. This m plus 2, when I change the value, then the work of my mod is going to be the same. So I'll say this is invariant. Okay, both are same. Same way goes with n mod 3. I'm going to divide my n by 3. After I change my value as n plus 3 and I divide by 3 also, this work is to get the reminder. Reminder dividing my n by 3. If I change my value of n plus 3, the work is going to be the same. So again, this is invariant. See the next one. This is our coming back to our usual method. 3 into m minus 2 into n. Substituting before, what will be my answer? 3m minus 2m. After substituting, what is my answer? 3 into m plus 2 minus 2 into n plus 3. This is my variable. So 3m plus 6 minus 2n minus 6. When you ignore it, you'll get it as 3m minus 2n. So before and after, my value is same. So this is also invariant. We go for the choice D. Choice D is 2m minus 3n. Substitute m plus 2 and n plus 3. You're getting the answer as 2m, 2 2s are 4, minus 3n minus 9. Sorry, this should have been minus 9. Sorry. Yes, this should have been minus 9 and my answer should have been 2m. Any of the answer is different. 2m minus 3n. Okay, I change this. 2m minus 3n. You'll get your answer as this is minus 9 and plus 4. I'll get my answer as minus 5. So my final answer should have been 2m. There's a mistake over here. 2m minus 3n minus 5. Anyhow, this is not same. 2m minus 3n minus 5 is not going to be the same. Hence, 2 into m minus 3n. All the other 3 are invariant. Only this expression, choice D alone, is not an invariant. There's a mistake over here, children. This should have been 2m minus 3n minus 9. So my answer would have been 2m minus 3n minus 9. Anyhow, it is not same. So this expression is not an invariant. So this is the explanation for your choose in your textbook children. Okay, I'll come back with one more video with another thing. Thank you, children. Please, again, I'm requesting you all to go through the videos again to understand the problem.